Hello, 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 hello. So, hello everyone, and very good evening. Hello everyone, a very good afternoon everyone. कैसे हैं आप लोग? Hello everyone, good afternoon everyone. So, after a long time, we'll be starting with a new lecture. I hope audio and video is clear. So, very good afternoon. I hope audio and video is clear. Please confirm it. Is audio and video clear? Is audio and video clear? Okay, so this is a revision class for GATE examination, and today we'll be taking the concepts of influence line diagram. Okay, so from now onwards I'm free to take up the classes for GATE classes. Okay, you note down the topics which you find difficulty in solving the question. We will discuss one by one all the topics, and we will try to cover the topics with the help of the questions. Okay, so in the previous lecture of influence line diagram, lecture 1, we have covered how to draw the influence line diagram for reactions. We have seen how to draw the influence line diagram for shear force and how to draw the influence line diagram for bending moment. Yes or no? Yes or no? And subsequently we have taken the concepts questions also for influence line diagram. Okay, so we'll go ahead. You remember that in the previous case we have studied that how to draw the influence line diagram for reaction. This is a simply supported beam. Okay, this is a simply supported beam. This is a simply supported beam. Okay, this is a simply supported beam, and there are two reactions over here. One is roller support, one is pin support. Okay, when unit load is moving, reaction at A and reaction at A and reaction at B. Do you remember in the previous class we have seen that how to draw the influence line diagram for reaction. If it is a simply supported beam, just remove the reaction, lift it by 1 unit, just remove the reaction. If I want to draw the ILD for reaction A, what is the shortcut? That is Mueller-Breslau principle. What is the shortcut for Mueller-Breslau principle? Remove the reaction at A, lift it by 1 unit, and the deflected shape will be the ILD for influence line diagram. Yes or no? That was the shortcut. This is lifted by 1 unit, so this is the reaction ILD for reaction at A. If I need to draw the ILD for reaction at B, ILD for reaction at B, how do we draw the ILD for reaction at B? Remove the reaction and lift the beam by 1 unit. The deflected shape is the ILD for reaction at B. Yes or no? Lift it by 1 unit. The deflected shape will be the ILD for reaction at B. You getting my point, everyone? Since today's class will be of shorter duration, this is the reason being we are meeting after so much of the gap. But from tomorrow onwards, I'll try to be consistent in the classes. Okay, So I'll give you today's time. In today, you discuss among your friend that in which topic you find difficulty in solving the question. In the coming days, at a regular pattern, I will discuss those concepts which you find difficult to solve the question. So today's class will be of shorter duration, but after, from tomorrow, we will take up the longer duration so that in a single class, a whole concepts can be discussed. Understood everyone? Understood? So this is how we will proceed in the revision of, we will proceed with the revision for the GATE 2025. Clear? Understood? Now the next concept what we have discussed was, okay, we will take up one question. Since we will take up one question, so the question says that there are 2-point load. I hope a very basic question we will take up. 2-point load are there. 2-point loads are there. They are 2 meters apart. 2 wheel load 10 km, 20 km are 2 meter apart. Look, solve this question. This is a simply supported beam. This is a simply supported beam and 2-point loads are moving. 2-point loads are moving and the magnitude for both of them are 20 kilonewton, 10 kilonewton. They are 2 meter apart. 20 kilonewton, 10 kilonewton and both are 2 meter apart. This is A, this is B. Okay. And the span for the beam is 10 meter. You need to find out maximum reaction at A. You need to find out maximum reaction at A. Maximum reaction at A. So this is the first type of question. Maximum reaction at A. Calculate it fast. Calculate it fast. This is very simple. This is a very simple question. Reaction at A and B. अरे भाई पढ़ो, यहाँ पर पढ़ो, पढ़िए, यहाँ पर पढ़िए. So the reaction at A will be, how do we draw the influence line diagram? How do we draw the influence line diagram? Remove the reaction and lift it by 1 unit. Remove the reaction and lift it by 1 unit. Yes or no? This is 1 unit. Now in order to get the maximum reaction at A, this is the ILD for A. Yes or no? This is ILD for A. This is ILD for reaction A. For reaction A. ILD for reaction A. ILD for reaction A. Understood? So look very carefully. In order to get the maximum reaction at A, 20 should be placed above the A and 10 should be placed 2 meter ahead of it. So the maximum reaction will be, you just find out this coordinate. This coordinate is find out by similar triangle. This is 10 and this is 8. This is 10 and this is 8. This is 10 and this is 8. Yes or no? This is 10 and this is 8. Okay. So what is the ordinate for this? What is the ordinate? What is the ordinate for this? Apply similar triangle concept. 1 upon 10 is equals to x upon 8. So this will be nothing but 0.8. Yes or no? This is nothing but 0.8. So what is the maximum reaction at A? What is the maximum reaction at A? Maximum reaction at A will be equal to maximum reaction at A. So what is the maximum reaction at A? That is 20 into 1 plus 10 into 0.8. So your answer will be 28 unit. Your answer will be 28 unit. This is your reaction. Understood? Understood everyone? Clear? So this is the first type of question from the reaction. We'll solve one more question. One more question on this is, instead of these point load, if let us suppose uniformly distributed load is moving on the beam, then you need to find out the maximum reaction. Understood this concept? Understood? Shall I proceed ahead? Now from now onwards, you can discuss the concepts which you want. I'll take up those concepts only, since the time is very less for gate examination. Now in the previous question, now another type of question is, if a UDL is moving, and the, look, if a UDL is moving, okay, 3 meter, and the intensity of UDL is 5 kilonewton per meter, span is 10 meter. You need to find out the reaction at A, maximum reaction at A. Now the next question is, you need to find out the maximum reaction at A. This is a type 2 question. Maximum reaction at A. Solve this question. Solve this question. This is what, how will you find out the maximum reaction at A? How will you find the maximum reaction at A? Solve this question. How will you solve this question? Now look, if you want to find this maximum reaction, remove the reaction and lift this beam by 1 unit. Lift this beam by 1 unit. Yes or no? Lift this beam by 1 unit. Clear? Now ahead of the 3 meter, if this is 10 meter, the coordinate is 1. So at 7 meter, what will be the coordinate? This will be 0.7. Now there are infinite number of point load. Infinite number of point load. The point load multiplied by the ordinate. The point load multiplied by the ordinate. So the best way to calculate this will be to find the area under the curve. To find the area under the curve. Yes or no? You just find the area under this curve. You'll get the answer. So reaction at A. So maximum reaction at A will be when? Maximum reaction at A will be when? Maximum reaction at A will be when the UDL is just above the reaction. When UDL is just above the reaction. Yes or no? We will get the answer. We will get the answer for this. So this is a trapezoid. How to find the area of the trapezoid? Half sum of parallel side into distance between them. So what is the area under the curve? Area under the curve is half sum of parallel side into distance between them. 1 into 1 plus 0.7 divided by half. Half sum of parallel side into distance between them. So distance between them is 3. So this is the area under the curve. What is the intensity of the UDL? 5. So you'll get the answer. This is the maximum reaction. This is the maximum reaction. Yes or no? Solve this question. So UDL can be treated as infinite number of point load. So I will take up the note over here. UDL can be treated as infinite number of point load. Infinite number of point load. Understood? You will get the answer. What is the answer for this question? Calculate this. So 12.75 is the answer. Now what was the concept for shear force? This was the concept for influence line diagram for reaction. Now what was the shortcut for influence line diagram for shear force at any point? This was the two concept. In the previous class we have seen the ILD for shear force also. We have seen the ILD for bending moment also. Do you remember the ILD for what was the shortcut to draw the ILD for shear force? Now ILD for shear force, ILD for shear force at any point. ILD for shear force at any point. Okay. I'm not getting your comments. What was the ILD for shear force at any point? Let us suppose this is a simply supported beam. This is a simply supported beam and I need to draw the shear force at any point C. Let us suppose this is point C at a distance A and this distance is B. Okay, so what was the shortcut? The shortcut was cut the beam at C and live on the right hand side. Raise the beam without removing any support. Raise the beam by B upon L, B by L unit, and on the left hand side deflect the beam downward by A by L, so that the total ordinate is 1 unit. Total length is L. You can see at point C, what is the total ordinate? B by L plus A by L, that will be 1. Let us suppose this is theta A, this is theta A and this is theta B. What is theta A? Theta A will be equal to perpendicular by base, A by L upon A, which is equals to 1 upon L. What is theta B? Theta B is equal to B upon L by B, that is equals to 1 upon L. So theta A and theta B are equal. What is the total ordinate at C? What is the total ordinate at C? Total ordinate C is will be equal to B by L plus A by L, which is equal to 1. Clear everyone? Understood? And the third concept was how to draw the influence line diagram for bending moment at any point. So this is the concept for shear force. What is the shortcut? If you need to draw the shear force at any point, okay, then cut the beam. On the right hand side, lift the beam upward by how much unit? This coordinate B upon total length. On left hand side, deflect the beam downward by how much unit? This is A by L, total length L. So the total ordinate at this point will be equal to 1. So the rotation of this influence line diagram, rotation, this is ILD for influence line diagram for shear force at C. ILD for shear force at C. Clear everyone? Yes or no? Now the next concept. Next concept is ILD for bending moment at any point C. Now look, ILD for bending moment at any point C. ILD for bending moment at any point C. ILD for bending moment at any point C. Let us suppose this is a simply supported beam and I need to draw the bending moment for point C. This is A, this is B. On moving the point load, so what is the shortcut to draw the ILD for bending moment? Assume an imaginary hinge at C. and lift the beam by AB by L without removing the support at A and B. Assume an imaginary hinge at C and lift the beam by AB by L. Yes or no? This coordinate is, let us suppose rotation is theta A. Here the slope for this line is theta B. Slope for ILD at B, slope for ILD at A. Now what is theta A and theta B? Theta A will be equal to perpendicular by base AB by L upon this is this, or this distance is A, this distance is B, and the total distance is L. So theta A will be equals to AB by L upon A. This is equals to B by L. What is the ILD slope of the influence line diagram at B? So perpendicular by base AB upon L and upon it is B. So this will be equal to A by L. So the total rotation theta A plus theta B equals to theta A plus theta B equals to 1. Theta A plus theta B is equals to 1. You can see very carefully. We will assume an imaginary hinge. This rotation is theta A and this rotation is theta B. So the total rotation is 1. Total rotation is 1. This is theta A, this is theta B, and this total rotation is 1 unit. Lift the beam. Assume, without removing the support, assume an imaginary hinge at C and lift the beam at C by AB by L coordinate such that the total rotation between these two lines is, total rotation will be 1 unit. Understood? Clear everyone? After this, we have seen one more concept in the previous class, that if I need to solve one question, one of the question is, okay. So in today's class, we'll see one question on this, and after it means tomorrow, in tomorrow's class, we will see how to draw the influence line diagram for cantilever beam, how to draw the influence line diagram for bending moment for cantilever beam, and then we will see how to draw the reaction for forces in the member of the truss. Clear everyone? So today is just a revision class, okay. Most probably tomorrow we will look for the concepts of influence line diagram for cantilever beam as well as for truss also. That will finish your ILD concept. Understood? So now look, this is a simply supported beam of span 10 meter, and I need to draw the bending moment. I need to find out the bending moment, maximum bending moment at point C. What is the maximum bending moment at point C? When 2 point loads are moving, okay, 10 kilonewton and 5 kilonewton apart. 10 kilonewton and 5 kilonewton, which is 10 kilonewton and 5 kilonewton. which is 2 meter apart. Which is 2 meter apart. You need to find out the maximum bending moment at point C. Will you be able to solve this question? Answer me in yes or no. Will you be able to solve this question? Okay, we will solve the question. How we can solve the question? We can draw the influence line diagram by rotating, without removing the support. Assume an imaginary hinge at C and lift the beam by AB upon L. AB means 6 into 4 divided by 10, that is equals to 2.4. 2.4 unit. This is 2.4 unit. If I need to find the maximum bending moment at C, we need to find this coordinate. So if the distance is 6, the ordinate is 2.4. If the distance is 4 unit, what will be the ordinate? You will apply the similar triangle concept. 2.4 upon 6 is equals to x upon 4. So x will be equal to 2.4 into 4 divided by 6. So this will be 1.6. Yes or no? This will be 1.6. Maximum bending moment will be 10 into 2.4. Maximum bending is 10 into 2.4 plus 5 into 1.6. So this is your answer. Kilonewton meter. Kilonewton meter. Find out the answer. What will be the answer for this? Answer the question. This is your answer. 24 plus 5 times of 1.6. Your answer will be 32. 32 kilonewton meter. Understood? So in ILD, today is just a class. Now tomorrow you can discuss with your friends at the same time in afternoon. At the same time, probably around at 1 p.m. I'll take up the concepts of ILD which will be left. So today is just a reminder class that from now onwards I'll be taking the revision sessions for the topics which is important for GATE examination. Clear? So I'll discuss with the management that the timing for the classes, most probably the timing for the classes will be from 1 p.m. onwards. And in the next lecture, I'll take up the concept of influence line diagram for cantilever beam, reaction for cantilever beam. I'll take up the concept how to draw the influence line diagram for shear force for a cantilever beam. For simply supported beam I have taken. Now in the next class I'll take up for cantilever beam, reaction, shear force and bending moment. Then I'll take up how to draw the influence line diagram for the forces in member of the trusses. Then that influence line diagram will be finished. So probably around in 2 hours I'll complete the influence line diagram. Okay. So today I'm finishing this class over here only. Okay. So that in the next class most of the student joins in the live class and discuss your doubts in the live session only. Okay. So today I'm finishing this class on here only. Thank you so much guys. Thank you. We'll meet in the next class.